Here's a worksheet, and let's see what this one looks like. And please join me in this one because this is sort of fun calcs on this. So we're told that we're given that we're asked to find the hydrogen ion concentration of an acid, hydrogen sulfide. This is a little bit different than you're used to looking at because when you have a weak acid like this, unless you're told otherwise, it'll dissociate into an H+, and it's only going to lose one of its ionizable hydrogens. So here's what we're going to write for our dissociation. This is going to dissociate like this. And this will be true every time we have a diprotic acid unless I tell you differently. Is that clear? So diprotic acid will lose one hydrogen only. Yes?
What is a diprotic acid?
It has two ionizable hydrogens like H2S. It's got two that it could lose. Now, let's go ahead and write our Ka expression for this. And that will equal my H+ concentration times my HS- concentration divided by this. Easy peasy so far, correct? Next, we are going to make an ice table. And I'm going to have to erase a little bit of this. So does everybody have this written down? Okay, so I'm just going to erase this part because I don't have enough room. Okay, so now my reaction is going to be H2OS, H+, and HS-. And we need to do our ICE. Here is my given initial concentration, 0.45 molar. What will be the initial concentrations that go here and here? 0. Does everybody remember that that's 0? Okay. Now, what we're trying to find, our unknown, is this value right here. This is my unknown. Do you agree that my H+ concentration has to be equal to my HS- concentration? Stoichiometrically, they're equivalent. 1 to 1, correct? So in terms of X, do you agree that this is going to increase by some magical number X? If this is a plus X, what does this one have to be? So my equilibriums will be X and X consecutively, correct? Then what does this X right here have to be? Minus X. So we're going to end up with 0.45 minus X. This gets to be sort of the fun part here. Anybody who's got a graphing calculator. So far, I haven't had anybody who already knew how to do this. I'm going to give you that my Ka, do I have it backwards here? My Ka is given as, I'm going to give you this, 9.1 times 10 to the minus 8. And you don't know this yet, but this is your given Ka. I'm giving it to you. You would have to look this up. So where did I get that number? It was given. That's going to equal, is it okay with everybody if I write x squared in the numerator? And 0.45 minus x in the denominator. Ooh, who sees where this is going? It is a quadratic. I'm going to erase this. And I'm going to erase this. And let's go ahead and would you please solve for, I like to have my x on this side. X squared equals 9.1 times 10 to the minus 8 times 0.45 minus x. Does everybody agree with that? So I'm going to get x squared equals, who can multiply these two numbers for me and tell me what they equal? I think it's 4.1 times 10 to the minus 8. Is that, so have I written this down correctly? Now I'm going to get all of my terms on this side, x squared plus 9.1 times 10 to the minus 8th x minus 4.1 times 10 to the minus 8th equals 0. Do you all agree that this is the quadratic equation? Okay, now let's solve these on our graphing calculators. Are you ready? What? Here's what I'd like you to do. I'd like you to go to your calculator and press apps and go down. I think it's usually a number 9. It's like it looks like about like this. Look for this. Look for this. Who found it? Do you have finance on yours?
Wait, on apps?
On apps.
I do have finance.
Uh-oh. That's been a bad thing today. Did you find the one that says PLYSMTH?
Yeah, it's number 9.
Okay, number 9. That's what it is on mine.
Wait, does that mean
Oh
I can't
my
do it?
goodness.
Who found it?
Wow.
Now, when you're in that, I know I've had people just like almost in tears with joy all day because of this. Yes, you can do all your quadratics on here. Now, are you on your quadratic screen? Once you're on that, then just go ahead and press enter. And once you press enter, I want to follow this so I don't say it wrong.
Root finder?
Yes, once you say enter, then press again and it will say like polyroot finder. And you should have highlighted on the top the number 2 because your largest power is 2. And once you're there, directly under the word next, which is your graph key, press your graph key. Who's there? When you've got your graph key, you're going to be prompted to put in your 3 coefficients with your signs. So your first coefficient is 1 in front of your x squared. Does everybody agree with that? Okay, so there's 1 coefficient. Here's your next coefficient, and make sure that this is a plus. If it's not a plus, and if you toggle over to that first one, you can toggle your plus right here. That one should be a positive. So go back and make that positive. Make that a plus, and then go over 1. And then enter that as 9.1 second EE negative 8. Then toggle over and make sure that this minus is a minus. And then you can toggle over or enter. Make sure that they're all in there correctly. And enter this as 4.1 second EE negative 8. When you've got them all, please notice that there's a solve button. Do you all see the solve button, which is also your graph? When you solve, you should have a plus and a minus solution.
Yep.
Your positive solution, they're the same, right?
Yeah, except one's
So you have one that says negative 2.0 times 10 to the minus 4th. And one that says positive 2.0 times 10 to the minus 4th. Both of these are molar. Which one can you not have? Negative. The negative. So your answer is 2.0 times 10 to the minus 4th molar. Who is happy they finally learned how to use that to do that? So,
If I have finance, do I just have to use the quadratic equation?
yes,
Oh wait, can you?
but you can download it, I'm pretty sure.
Can you also just graph it and then do the finding stuff on there? It was really annoying.
You could, but I'm going to show you something better. Do you have a graphing?
Yeah, I've used this before.
Oh, you used it before. Did you get it, Mason?
Yeah, I got it.
Okay. So now, here's what I'm going to tell you. So listen carefully and don't look down, look up here. Do you agree that this number, whoops. Do you agree that this number right here is very small?
Yes.
That is a very small number. Because it's very small, we are allowed to do the following. We're allowed to get rid of this minus x right here. And we're allowed to get rid of this minus x everywhere around here. I'm going to erase all this. And our new equation, when we ignore those, yes. So our new equation, when we get rid of all this, is going to be, well, I want to do that. Maybe I have to erase less at a time. This is taking a bit longer than I'd anticipated. Okay, so now my 9.1 times 10 to the minus 8 is going to equal x squared over 0.45. Would you solve this by doing the following? Do you agree that solving for x, we will get the square root of 9.1 times 10 to the minus 8 times 0.45? Go, solve that for me and tell me what you get. You're going to get the exact same answer. Don't forget this is concentration, so it needs a molarity. I will never give you a problem on an assessment where you have to use the quadratic, but I like to take a little bit of time right now to let people know where the quadratic is and practice it. So the answer for this one is 2.0 times 10 to the minus 4. Okay, our next problem is not much different than this. We are going to be working with ammonium chloride. Now, interesting here, my chloride is a spectator ion, so I'm going to ignore it. So as I'm making my equation here, I can see that I've got NH4 plus, and it's going to be plus water, which we'll leave out because it's a liquid. And that will form H3O plus and NH3. So we're going to go ahead and do our ice table. And just so we don't get mixed up, I'm going to X that out, if you will. And you agree that I'm given that this starts at 0.60, which means this is 0 and 0. Is everybody good with what I've written so far?
Can you just write H plus, or do we have to write H?
You may write H plus. I find it easier to do these like this, but absolutely you may write H plus. Now, let's look at our second line, our change line in terms of X. What will my NH4 be? Minus X. My H3O plus? Plus X and plus X. So again, I'm going to have this, and 0.60 minus X. Look at this value, and we know that for us, we don't want to hit, this will be approximately equal to 0.60. So we're not going to use that 0.60 minus X. We won't have to do the quadratic then. Is that clear to everybody? We can ignore that step. Now, next, we've got a new thing here. I'm going to switch colors. Next, I go to my tables, I'm looking up, and I can find the Kb for NH3 is equal to 1.8 times 10 to the minus 5. I just looked that up. You will never have to know those. I will give them to you. On this particular worksheet, I'm giving this to you. But there's a problem here. What is that letter? And we're dealing with an acid. To find our Ka, all we have to do is take 1.0 times 10 to the minus 14th divided by our Kb. And I think that is 5.6 times 10 to the minus 10. Can somebody double check that for me? And again, that'll be,
Negative 10, yep.
what?
5.6 to the negative 10.
Yes, very good. So now, next, we can do our next order of business here. So let's take our 5.6 times 10 to the minus 10th equals, is everybody good if I go x squared over 0.60? Solving for x, you will get the square root of 0.60 times 5.6 times 10 to the minus 10. Who's got it? 1.8 times 10 to the negative 5. Is that right? Okay. Almost there. What did I ask you to solve for? I asked for pH. And this is our concentration of our H+. So we are given our H+ concentration as 1.8 times 10 to the minus 5th molar. To find our pH, we will simply take the negative log of that number. And if you guys are lazy like I am, you can just go negative log second answer and it'll come up and you should get 4.74. And please notice that 4.74 has 2 decimal places and this have 2 sig figs. So 2 sig figs means 2 decimal places. Do you remember that rule? Just to make life interesting. One more I wanted to do today. This one's super easy. So here I'm given HBRO. This time I'm going to just go HBRO, and we know that that's going to dissociate into H plus and BRO minus. Do we even care what BRO minus is? We do not. Let's do ice. This is 0.25. Keep filling out what goes here. What goes here. Okay. Now this is interesting because I'm told that I have a pH, which is 4.65. From that, we can find our H plus concentration by taking 10 to the negative 4.65. That's your anti-log key. So somebody do that for me, and I believe you're going to get 2.24, I forget, times 10 to the minus something. I remember the 2.24.
2.24 times 10 to the negative 5th.
Negative 5th molar. So here, I know my final concentration is 2.24 times 10 to the minus 5th. Do I know that these two values have to be equivalent? Yes. And this one will be 0.25 minus 2.24 times 10 to the minus 5th. And we're solving for Ka this time. So do you agree that this will be 2.24 times 10 to the minus 5th squared divided by 0.25 minus, put that in parentheses, 2.24 times 10 to the minus 5th. Okay, and when I did this, I believe to 2 sig figs, I got 2.0 times, I forget, 10 to the negative something. What time do we get out of this class?
45.
Well, I'm going to be just about perfect here. I wanted to get through this problem. 2.0 times 10 to the,
Negative 5.
I don't think it's
Negative 9.
negative ninth. And remember, our Ka has no units. So the biggest thing to remember here is when asked for concentration, Don't forget units of molarity, moles per liter or molarity. And for Ka or Kb, no units. And we only did one with a pH right here, but when you're given a pH, you can always get your H plus concentration. Reagan?
I was gonna ask like, how.
Yes.
I kind of missed that.
So you have to really evaluate each problem. I'm never going to give you super hard ones. You're only going to do easy ones like this. You will never have to do a quadratic. Now, I made you do it right here in this one, but that wasn't hard because it wasn't like we had to solve for a quadratic. And if you tried to do this and took 2.24 times 10 to the minus 5th squared and just divided it by 0.25, you're probably not going to get a different answer. Does that make sense? Because I can see this is so negative, it would have almost no impact. And if you stop and think, I want to go back to one more problem since I have a little time here. This problem right here, where I said you could ignore the 0.45, watch what happens if I take 0.45 minus 0. We had 0.0020. That will come out to this value. I can only, whoops, that should be a 4. So this can only be significant to here. What does that round to? 0.45, correct? Even if I wanted to go one more 5, I'm doing it again. 49. Even if I wanted to round to right here, it's 0.450. Do you agree? That's why it just really has no significant value. Okay. Goodbye, everybody.